Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host once again for today's show. You're stuck with just me today. I'm going to be talking about side detection modules or blind spot monitoring systems in automotive applications today. Got a number of things to cover there, along with some case studies or case study, depending on how you look at it. We'll cover some General Motors stuff related to the side detection modules, because they seem to have the most problems with those, or at least the ones that I'm getting called into the shop for. Before we get going, just got back from Vision last week, and I'll have some people on the podcast in the near future to talk more details on that. There's a lot of really cool stuff there. Enjoyed my trip quite a bit. Had an interesting ride home to get back from Kansas City, but I'll probably talk about that later. For everybody that I got to meet and talk to, and all the kind words that people had for me at Vision about the podcast, and just meeting people in general, that was so cool. Really made my weekend, and I'm just really happy to be able to get to meet some people in person, put faces to names from people that I've just talked to online. Really, really cool. So thanks for, everybody that was there that I got a chance to talk to. And if you weren't, make sure to, make plans to make it out to these training events. Even if it wasn't for the training, just the networking and talking to people is worth the price of admission. So anyways, really enjoyed Vision, learned some stuff, met some cool people. Now I'm back and invigorated and ready to go to continue diagnosing some vehicles. So today I wanted to talk about the side detection modules or the blind spot monitoring systems in vehicles, mainly because I've been getting a lot of calls for them lately into shops. And like I mentioned, it happens to be General Motors vehicles that I'm getting calls for. We'll talk about why that is as we progress, but these are used on almost all vehicle applications nowadays, if you look at brand new cars, and they've been used for quite a while. This isn't new technology by any means. The system was built into 2003 Volvo XC90s. That's the earliest model that I could find that utilized an actual camera and or radar system in order to detect an object in your blind spot. And that's what we're trying to do, right? We're trying to the computer in the car is trying to identify if a car is in your blind spot as you're driving down the road. So this would be on a multi-lane highway or freeway where you have two lanes traveling the same direction, and you may want to change lanes at one point or another. Okay, if there's a car in your blind spot, which means you can't see the car in your rear view mirror, you can't see them in your side view mirror, but they're there, and if you move over, you're going to cause an accident, right? And we're all familiar with what a blind spot is. I shouldn't really need to explain it, but just so we're clear as we're moving forward, that's what these systems are meant to do, is to detect if a car is in your blind spot and alert you with some sort of visible or audible or tactile warning. Most vehicles nowadays have that little amber illumination on the side view mirror. And so if you're driving and you're in someone's blind spot, you can actually see that on most vehicles. You'll see that little light come on. And it's nice to know that, hey, at least the driver of this other vehicle has a system in place to let them know that I'm in their blind spot. And from when I first began driving and these systems weren't even really a thing, I always avoided being in someone's blind spot, right? If I was in traffic and I knew that I was in that position as the driver of the other car and I was in someone's blind spot, I would move out. And I think that kind of had to do with riding motorcycle for a while. Is you definitely don't want to be in someone's blind spot when you're on a bike, because obviously you're going to be much smaller. It's much easier for a driver to miss you. And of course, if they move over, it's not just a car accident. You could have serious physical injury or death if somebody, runs you off the road while you're on a bike. So I always make a point to not be in someone's blind zone when I'm driving. But of course, I have blind zones of my own when I'm driving my work van. I have a Transit Connect, and there's just basically front windows and there's no rear windows. And so the blind spots, especially on the passenger side on this thing, are really bad. So I stuck one of those little fisheye lenses on the side view mirror on the passenger side. And I always move, check around my shoulder by moving my head to check my blind spot before I move over. And that's the way I was taught to drive, most of us. Same thing. We're going to just move our head over, check the blind spot, and then we can move over. But on that Transit, that passenger side, I can't see it without that fisheye lens. So that's huge because it expands my vision to the blind spot on the passenger side. But anyways, again, this is all pretty basic standard stuff that we're all familiar with. But we're going to be talking about these systems that assist the driver. And, of course, the argument can be made that it's just making people lazy and you should be turning your head and checking your blind spot. Why do we need these systems? I get that argument, but fact of the matter is these are a thing and they do help drivers prevent collisions and save lives, hopefully. When I was doing some just preliminary research on this topic, just for how these systems have been utilized, for how long and how they're constructed, I read an article which was actually pretty interesting. It's an SAE paper from 1995 where this guy, the title of it is The Geometry of Automotive Rear View Mirrors. And this guy basically makes an argument that there is no blind zone in a vehicle if you adjust your side view mirrors properly. And just a quick synopsis of this: if you are sitting in the driver's seat and you lean your head over to where your head would be placed against the window of the driver's door, you adjust your mirror in until you can just see the side of the vehicle. And then you do the same thing by leaning over to the right side, so your head is now in between the two front seats, and then you adjust the passenger mirror the same way, just so that you can see the vehicle in the side view mirror. And then you can check that this works, because the idea here is that it's going to be able to see cars in your blind spot. And his argument in this paper is that there is no blind spot. You just have to adjust your mirrors accordingly. And you can verify this by going out and driving, and you can look in your rear view mirror. Of course, a car would be approaching you from behind, and eventually that's going to be in your blind spot where you no longer see this car in the rear view mirror, and you may not see it in the side view mirror. But with the mirrors adjusted properly, you would see this car in the side view mirror. So before it leaves your rear view mirror, you should see it in your side view. And before it leaves the side view mirror, you should see it in your peripheral vision. Then you have the mirrors adjusted correctly. I haven't tried this yet. I just read it, this article, but he uses geometry and stuff like that. And it was actually involved with patenting a additional mirror that was equipped on Fords first, where it's the mirror that is underneath the side view mirror. So you'd see two mirrors set up kind of like that fisheye lens, the little round one that you stick onto the side view mirror. Same idea, it's just to eliminate blind spots. Anyways, I realize none of that has to do with actual blind spot monitoring systems, but just a little setup here as we get into it. So the systems I'm going to be talking about are going to use radar mostly. There are some systems that utilize camera, but most of these systems are going to use radar sensors or modules that are going to be located in the rear corners of the vehicle. A lot of times these are mounted up to or behind the rear bumper, one on the left rear corner, one on the right rear corner, because we want to be able to detect other vehicles on both sides, not directly behind, but basically to the rear corner of each system. And one of the other reasons that I wanted to bring this up, I was called earlier this week to program a tail light in I think it was a 21 F350. And I thought that was an odd call when they said, hey, can you program this tail light? Service information, according to the shop, says you have to program this headlight or this tail light once you put it in. I was like, okay. And so I checked out the service information for myself because it sounded strange. Well, as it turns out, in the Ford F-Series pickup trucks, they put the side detection module, or they call it SOD, side object detection, inside. It's built into the taillight assembly. So the radar sensor slash module, and a lot of these are modules, as we'll find out as we go through this, are built into the taillight assembly. So if you replace the taillight assembly, you have to do a PMI and actually program the module in order for it to work correctly with the rest of the vehicle. So pretty interesting there in case you run into any of those new Fords. They may do that on other applications too, but a lot of these are located behind the bumper. Now, again, the goal of these is to identify a vehicle that is approaching in an adjacent lane, moving in the same direction as the vehicle. And some of these will have a minimum speed for the vehicle in order for it to activate. Some of these, there's actually a GM service bulletin. If it doesn't see a vehicle approach either the same direction or opposite direction for a period of time, it will disable itself because it thinks it's blocked. I think it was like 15 to 25 minutes. So if you're in a very long stretch of road with no other traffic on those GMs, it's normal for itself to disable until there's an ignition cycle. I thought that was kind of interesting. You'd probably have to live in a very specific spot in order to experience that, but they have a service bulletin, so obviously it happened. But the goal of this system, again, is to detect a vehicle that's approaching you in an adjacent lane, traveling the same direction as you. So what that means is if you're just on a 2-lane road where you're moving opposite directions and a car comes by your vehicle going the opposite direction, it's not going to alert you about that vehicle, even though the radar may pick up that vehicle, it's moving in the wrong direction. Or let's say you're driving down a road and on the right-hand side, there's a bunch of parked vehicles and you're driving past these parked vehicles. Now, those vehicles would be in a spot where it could be considered your blind spot. But because those vehicles aren't moving, it's not going to alert you. It's only going to alert you if the vehicle in the adjacent lane is moving and is moving in the same direction as you are. So it's actually pretty interesting what these components are made to detect. And that's all through radar technology, which is pretty interesting. And I have a loose grasp on, but John Thornton actually has an ADAS class. I think you can purchase it still through automotive seminars, where he breaks down how the radar systems work and the frequencies and the Doppler effect. It's pretty interesting stuff. I don't know that you'd use it to fix a car, but I like to know how this stuff works. And it is functioning off of radar, which is electromagnetic waves, which travel very fast and it reflects off another object, bounces back to this radar sensor or module, and then it's going to determine not only the speed of the object that it detected, the distance away of that object, and also the angle that it's traveling. So it's a lot of stuff that we can determine by bouncing electromagnetic waves off of another vehicle. And these are going to operate mostly in the 77 gigahertz. Now, this radar is operating in the microwave spectrum of the whole electromagnetic wave spectrum. It's about 77 gigahertz. Now, if that doesn't mean a whole lot to you, I'll put a link in the show notes. I had a whole episode about electromagnetic waves and frequencies, and it has to do with RKE transmissions, and I was having some range issues with a remote start on a Yukon, and I went into pretty in-depth as far as the electromagnetic wave spectrum and how that's used for so many different things. But I'll put a link in the show notes if you want to check out that episode. But anyways, we're using these electromagnetic waves to bounce off of other vehicles. And when I was researching for this episode, I was actually thinking about, I'd never really put any thought to this before, but I was like, if every vehicle out on the road has radar, which it's not quite, but it's going to get that way eventually, where every single vehicle out there is using radar, and maybe some of these radar units are using the same frequency, is there going to be interference? And I came across another article, which I'll put a link in the show notes because it's pretty extensive and it's it gets pretty scientific as far as the details on this, but this is a problem that people are concerned about in the radar community. I don't know if I'm using that term correctly, but there's people that obviously dedicated their careers to creating these systems, and there's not a whole lot of regulation or conformity within the automotive realm when it comes to these radar sensors. And it's pretty interesting in this article where they lay out these are the problems that are going to be present. They're saying by like 2030, there's going to be significant radar congestion if something's not done about it. And I'm sure they'll figure it out one way or another, but I thought that was pretty interesting. There's a bunch of radar signals out there bouncing off vehicles. How do we not get interference? How does one module detect its own frequency from another one that's maybe from the same car, right? What's the difference? How does it pick that up? And again, a little beyond me, but the article's pretty interesting. So I'll put that link in the show notes as well if you want to check that out. The other thing that I read within there is Tesla is actually moving away from radar. It's going to try to move away from radar completely and go to just camera systems, which of course would eliminate that. Now, of course, there's things with weather and things like that that cameras are going to have issues with. Most vehicles now are going to use some sort of combination with cameras, radar, LiDAR, ultrasonic, sonar, things like that. So, but let's get into some real life stuff here, some real life day-to-day application and where we're going to see this stuff as technicians. The fact of the matter is these modules, especially the ones that are placed underneath or behind the rear bumpers, and this may be true of like forward-facing radar as well. I just haven't run into it as often, but I'm sure I will as time goes on. But these side detection modules have been around for quite some time on GM vehicles. And where these modules or sensors are located, they're exposed to water and, where I live, salt. And so water intrusion into these modules is a major problem. And you've probably run into it before. GM is definitely not the only one that's susceptible to this. I've seen this in Chryslers. I've seen this in Mercedes vehicles. I've seen this in Fords. They are susceptible to water intrusion because of their location. They're getting splashed with water and salt and whatever else is on the road. And they have corrosion problems. They'll get into the modules. I mean, the GM ones literally swell up and corrosion starts coming out of the seams of these modules. Okay. Obviously, those systems are not going to work once that happens. You don't need me to tell you that, but this is what happens, and it's what we run into quite often as technicians. Now, on some vehicles, for instance, Chrysler Town & Country that I worked on recently, this isn't that big of an issue. I mean, unless you're relying on that system to drive your car every day, you can, I mean, in these Chryslers, you can actually turn this system off. Toyota has it disabled. You can just push the button and your blind spot monitoring is off. It won't activate. Maybe you just don't like it for whatever reason. And on some of these systems, these modules, or in the case of the Chrysler vehicle, let me start with that. It was Chrysler Town & Country, and it had the left side object detection sensor that was disabled and it was corroded. The sensor fed its information into a blind spot monitoring module, which was located up inside of the vehicle. And you'll see where I'm going with this once I get to the GMs. But if one of these modules is disabled, the blind spot monitoring system is the only thing that's disabled. The rest of the vehicle's features are still functional, and it won't disable anything else on the vehicle. Again, once I get to the GMs, you'll understand why I'm referencing that. But you could just turn this system off through the dash, and besides the fact that it doesn't work, you'd never know there was an issue. And that's what the last customer I had actually did. They're like, I don't really want to replace that $500 module. I'm just going to turn it off. Okay, fine. Mercedes that I dealt with a couple months ago, same thing. The module was failed, and I don't know if there was a disable on that one, but the module, it was feeding its information on a dedicated line into the front SAM. And the signal acquisition module, I think it is. It's like a body control module. Again, that module failed. The only issue was that system was disabled. Now, I do believe that Mercedes had a few more warning lights on the dash, but completely functional otherwise. Now, when we get to GM, it's a little bit different. GM decided when they created these systems, and they're still doing it till at least 17, probably beyond, but that's the newest one that I've dealt with. They actually put these modules, these side detection modules, right onto the low-speed bus. All right, so a vehicle network that's connected to a bunch of different modules throughout the vehicle. And of course, it depends on the application and the vehicle, what it's going to be connected to on that low speed bus. But there are mission critical modules that are going to be on that low speed bus, namely the theft deterrent module, keyless entry module, body control module, instrument cluster. There's a number of different modules that are going to be important for vehicle operation that are connected directly to the same network that these side detection modules are connected to. Now, where this becomes an issue is when these modules corrode, like I talked about, they have a water intrusion issue, they can ground out or corrupt that low speed bus. And it happens pretty frequently. And when that happens, okay, all those modules I mentioned before, like theft deterrent module, for instance, it's one of the most common ones that disables a vehicle. Once that network's taken down and that theft deterrent module can't send its information or can't get information on that low speed bus anymore, you're not going to be able to start that vehicle. There's keyless entry modules. For instance, once those are disabled, if it's a push button start, nothing will happen in that vehicle unless you put the key into the pocket. I had one of those recently on I believe it was an Impala, a newer Impala. And if you put the key into the pocket, it would start up and run with a push button. And when you take it out, you could push the button all day long and nothing happened. And actually, Pedro Della Torre had a awesome presentation at Vision where it wasn't a side detection module, but it was the low speed bus on a GM that was down. And he was talking about the GM bus diagnostic tool. And he was able to determine exactly why this was happening, why you could, when the low speed bus was down, if you had the key in the pocket, it would key up, but if you were to take the key out, it wouldn't. And it's because there's a direct data line to the BCM from that key pocket that fed the key information and allowed the vehicle to start. But in order for the key to be picked up, if it's just in the vehicle with that low speed bus down, it's not going to happen. And of course, looking at a wiring diagram helps to understand that a little bit. But the point I'm trying to make here is that a vehicle can be disabled from that low speed bus being pulled down. And this, for whatever reason, really confuses shops. And I think it's the shops that I'm going to, of course, they're not well versed in network diagnostics and module communication. And so they'll plug into one of these vehicles that doesn't start, whether it be a proximity key or a blade key, and they can talk to critical modules with a system scan, like the engine control module and the transmission control module, ABS, maybe even the BCM on the high-speed network. And of course, they can't talk to everything on the low-speed bus, or, in some cases you actually can. It depends on how the network's being affected by one of these modules. But they're not seeing where the problem's actually coming from. There's not codes pointing directly towards the side detection modules not being on the network or not communicating. And I think that goes more to show, again, just a lack of understanding of the whole vehicle. When we get into something and we want to do a DTC scan, we've got to look at the vehicle as a whole and understand what's actually equipped on this vehicle when we do a system scan, right? Understand the network topology, understand the module application for that specific vehicle. What should I expect to see when I scan this vehicle? What is actually on this vehicle? What do we need for this vehicle to start? And of course, again, the shops I'm working with, they don't have that scope for various reasons that I'm not going to get into right now, but they're kind of lost, basically. They don't know where to start, because this vehicle won't start. And I've had some shops replace various components and attempts to fix this and not get anywhere. And that's usually when I'm called in. And really, again, it's just a matter of scanning this thing, seeing that either A, I can't talk to anything on the low speed bus, or B, I can talk to the low speed bus, but there's a number of communication codes in modules on the low speed bus. And again, it depends on exactly how these modules are affecting. I had one recently where that entire bus was just grounded and there was nothing. And that was from one of those modules. I've also had it where the messages are just corrupted, and you can still talk to stuff, but you'll have intermittent communications with modules. Modules cannot get the information across that they're supposed to because that single wire network, and I don't know if I mentioned that, it's a single wire network on these, is corrupted and the data can't be sent that it needs to. The BCM on these vehicles is the gateway. It's going to take that low speed data and transfer it to the high speed in order for the ECM to do its thing as far as engine operation. But again, that low speed bus needs to be functional and not corrupted in order for that important information like key position and theft deterrent, things like that, in order for the vehicle to operate. So how do we identify that it's the side detection modules that's causing the low speed bus to be down? Okay, so we've identified, okay, the low speed bus is down. You can do this right through the DLC, put your breakout box on there, throw your U-scope on, I think it's pin 2 on most of these GMs, and take a look at it, and it should be a nice, even, flat square wave. I'm trying to actually remember the voltage off the top of my head. It's either 0 to 5 or 0 to 7, but it should look like a nice square wave, and when these things are messed up, it's pretty easy to spot. Now, GMs are also really nice for having a network comb that you can locate. And in the SUVs, there's usually 2 of them where you can separate out legs of the circuit, right? And there's lots of classes and videos on this where people will remove the comb and they'll add in legs at a time onto this low speed bus until they find the one that's corrupted. So I'll throw a link in the show notes to Keith Perkins' video that he has. He talked about that in his network class at Vision as well, where we're separating the network into several legs in order to identify the portion of the circuit that's corrupting the data. And that's how we would do it, to identify that a side detection module is what's taking down the network. Now, here's a bit of caution on these GM vehicles. Now this spans a lot of different years. There's a lot of different applications, so it will depend on what you're working on. But I'm going to give you a specific example here. This is a 2013 GMC Acadia. Had the exact scenario that I'm talking about. Low speed bus was corrupted on this one. The vehicle would start sometimes, not other times, bunch of communication codes. Okay, I jump into it, pretty quickly identify that the low speed bus is corrupted with, I think I was using the Pico on this one, just connected to the DLC with a breakout box. Okay, so this vehicle has 2 splice packs for the low speed bus. So I start with the splice pack that's up under the dash, and I separate the comb and I add in modules until I find the corrupted leg, which happens to go to the rear splice pack, which is back at the back side of this Acadia. So I go back there, I remove that comb because it's a second comb, and I start adding in legs of the circuit until I find out that it's going to the left side detection module. And here's the thing. If you look at the OE network diagram for this GM, you will see a wire going to the left side object detection module. Okay, now that was the circuit where if I added it back into the network, it corrupted the network. Okay, cool. And that's what we're talking about today, is side object detection modules. So why wouldn't it? So I reach under the vehicle and I unplug the left side object detection module. Okay, cool. And now everything is good to go. I have both the combs back in. I have the network completely together, except for I unplugged the left side modules. And this is one of the first ones that I had ever experienced on this. This was a few years ago. So I checked powers and grounds to the module, and that is something you definitely want to do on these because it's pretty common for when these things swell up with corrosion, they'll pop the fuse. And of course, you're not going to be able to program the new ones until you have power there, but I had power and ground to this one. And again, once I unplugged that left side module, I was good to go. So I told the shop, okay, get a left side detection module, put it in there, and then we'll get this thing up and ready to go for you. I got to program them. These are modules. You have to use SPS or SPS2 in order to program them once they're in. They go really fast. It's like, I don't know, 45 seconds, and these things are programmed. So it's pretty simple to do that portion. But anyways, the shop calls me in, they install it. I go back in to program this thing, and my programming device was having all kinds of issues. And I actually was able to program the left side one after a few attempts, but after I got it programmed, the vehicle still wouldn't start. And I hook back up to my low speed bus and it's still corrupted. I'm like, what the heck? I go back, I unplug the left one. Again, cleans it up. I'm like, what's going on here? Again, this is one of the first ones I had dealt with on one of these. And again, going back to the network diagram, if you look at it on this vehicle and you look at the leg of this circuit, it's a green wire, goes to that side object detection module. That's it. That's all you see on this network diagram. Now, if you look at two other diagrams, the redrawn, which usually isn't helpful, but in this case, it definitely would have been, or you go to the actual side object detection diagram through GM on the OE side, you will see there's another wire that goes from the left module over to the right side module. Okay, so if you think about like a GM CAN bus, how they're daisy chained, where it's like an in and then an out, right? So if you unplug one module, you're taking several other modules off the network in a GM CAN bus. Well, it's the same thing for the side object detection modules. The rest of the low speed bus is just legs off of that comb. But for the right side module, they wire the network to the left side through the left side module. It can contribute its information internally and then back out over to the right. And what that means is if I unplug the left side module on these GM vehicles, I've also separated the right side module. And I've looked at several diagrams since. Some of the GMs include this in the network diagram, others don't. This GMC did not. And I wasn't paying enough attention to realize that that right side module needed the left side to be plugged in. Well, the right side was the one that was corrupting it. Now, there's some other things I'm going to talk about here as far as module replacement, but that one burned me because we had to do the other side as well. That was actually the one. So the right side's almost like a slave module, even though it's just an extension of that low speed bus. Now, as far as replacement goes on these things, one thing that you want to check for, and there are service bulletins on this. They actually had an extended warranty on a lot of vehicles, but you need to check the harness connectors and the harnesses themselves. They have issues with corrosion. Some of the fixes for these in a service bulletin is to replace the harness, both modules, and they actually, on the Impalas and some other vehicles, they have plastic covers that they have you put over the modules to help prevent further water intrusion because they were having such an issue with these things. They would last a couple of years and then they'd be replacing them again. So there are service bulletins, there are kits that you can order. And here's the deal. I would suggest that you replace both modules, or you recommend that both modules be replaced for a few different reasons. The service bulletin in some of these situations calls for it. If one module's failed, honestly, the other one's probably not too far behind. And these are easy to see too. If you shine a flashlight up behind the bumper, you'll see the corrosion in these things and they swell up. And like I said, once one is swollen up like that, the other one's probably not too far behind, but they've also had a number of updates to these modules in the trucks specifically. And to prevent any issues as far as software and programming goes, I always recommend the shop do both modules, fresh, brand new. They're probably updated parts, and then we can be good to go and we won't have any more issues. But make sure to check the harness because I've seen corrosion issues at the plugins as well. And these terminals are so small, it's not even worth trying to clean them up. You just get the new harness and then the system's back up and ready to go. And again, on these GMs, unless you were to leave them unplugged on the left side and cap off that wiring, you can't just turn these systems off. If they're connected, they're susceptible to being able to pull down that entire low speed bus and disable the vehicle. One other thing that I found interesting, at least on the GM modules that I've replaced for the side object detection, there's no actual ADAS calibration. There's no targets required. Service information doesn't even have you go on a test drive. I mean, I guess I would just to verify that they're working properly, but I thought that was pretty interesting that a lot of other systems like front facing radar and windshield cameras all need some type of calibration, whether it be dynamic or static. Some of them involve targets, some of them involve driving the vehicles and operating with a scan tool. These side object detection modules don't require that. They're just like, here, slap it up in the bumper and it goes into a plastic slide with a clip and program it and clear codes and you're good to go. So of course that may change on newer models, but again, at least up until 17, I haven't seen any calibration procedure for these. So it's just a replace, program, and go. But that's all I've got today on side object detection modules. If you live up in the north here, you've probably already seen some of these. If not, you definitely will at some point or another. But just want to thank everybody again for listening to the show, and again, all the kind words that I've gotten over Facebook and at Vision. Really, really appreciate it. We're going to keep rolling here. I've got a lot of really cool guests coming up. I didn't get to any at Vision. I decided just to enjoy my time there. But I talked to a lot of people that are going to be on the show in the near future. So look out for those episodes. And thank you for listening. But with that all out of the way, let's get out there and start fixing the world one car at a time.